for 8b.8, we're going to use the properties of logs that we talked about earlier last time, and then we're going to use that to find other logs. So as just quick reminders, product rule. When I am multiplying inside the log and I want to split it up into two, I can split it up, my insides into two logs that are being added together with the same base, okay? If you want to go backwards the other way and you have two logs that are being added, you multiply the insides, okay? Quotient rule is the opposite. So when I am dividing two numbers, I can split them up into two separate logs using subtraction. So when dividing, you subtract your logs. Power rule, when you are raising a log to a power, so I have my inside raised to a power, I can bring that power out in front and multiply it by the log. So when you're raising to a power, you're multiplying your log. And then I also wanted to remind you guys of the special rules. So special rules mostly have to do with logs with the same base. So if I am raising an exponent with a base of b to a log, and both of my bases are the same, you can drop your bases, and your answer is whatever you were taking the log of. And then in the opposite fashion, if I have a log with a base of b, and inside is an exponent with the same base, those bases drop, and the exponent is my answer, okay? And then anytime we're taking the log of 1, your answer has to be 0 because the exponent of 0 is what gives you 1. Anything to the 0 gives you 1, okay? So you have to have a 0 exponent there, okay? So let's look at a couple examples. The first thing I want you to write down is this given information. So we're going to be using this for all of the example problems. Okay, so given. Log base 10 of 36 equals some number A. I don't know what the number is, but I'm telling you that it's called A. And log base 10 of 4 is equal to some number B. Okay, and then I do want you to write this down also. For all of the examples, you are going to be finding the following logs in terms of A and B only. So in our examples, I'm going to be giving you logs of different numbers, but I want your answer to be in terms only of the variables A and B. So we're going to have to do some substitution here. Okay, so first problem. Okay guys, first one, we have log base 10 of 144. Now, I told you at the very beginning that I want our answer to be written only in terms of A and B. And we know that A is log base 10 of 36 and B is log base 10 of 4. So what we're going to try and do here is we're going to try and rewrite this log so that it's only in terms of 36 and 4. Any ideas of what we could do to change 144 to be in terms of 36 and 4? How can we rewrite 144? One idea is that we can rewrite 144 as 12 times 12 or 12 squared, but that's not 36 and 4. So we need to do only in terms of 36 and 4. Because that's 36 to the 4th power? That's really big. 36 squared is really, really big. Because if you guys look, 25 squared is 625. So 36 squared is going to be too big, let alone 36 to the 4th. 4 to the 36 is also going to be really, really big. 144 is 36 times 4. So let's rewrite this as log base 10 of 36 times 4. Do you guys agree that 36 times 4 and 144 are the same? So did I change the value at all? No. Okay, so here is where a lot of students would say, okay, I have log base 10 of 36 times 4. So I can replace 36 with A, and I can replace 4 with B, and then I'm done. My answer is A times B. That would be incorrect because I'm telling you that A is log base 10 of 36, as in the entire expression log base 10. Right now we have log base 10 of 36 times 4, so they're not individual. So guys, if I can only replace A with log base 10 of 36, is there a way that I can rewrite this expression so that I have them separated? Let me rephrase. Log base 10 of 36 is equal to A. My eventual goal is to be able to replace the expression log base 10 of 36 with A. I can't do it right now because right now log base 10 of 36 has a times 4 on the inside.
So would you do log 10, 36 plus log 10, 4?
Yes, we would use our log properties to split these up into two logs. So that would be log base 10 of 36. Since these are being multiplied, what do you do when I split them up? You add. So this is going to be plus log base 10 of 4. Now can I substitute? Yeah, because now I have log base 10 of 36. What is log base 10 of 36 equal to? A. So substitute A plus, what is log base 10 of 4 equal to? B. So we end up with A plus B. So example 2, we have log base 10 of 16. How can I rewrite 16 so that it's only in terms of 36 and or 4? 4 squared. Okay, so this would be log base 10 of 4 squared. There's actually two ways you can do this, so I'm going to do both ways. Can anybody think of another way to rewrite 16? Yeah, if we do it 4 times 4, okay? 4 squared and 4 times 4 is the same thing, but students do it both ways, so I want you to see it both ways, okay? So let's do both. Let's do the left-hand side first. I can only replace log base 10 of 4 with B, but right now I have log base 10 of 4 squared, so what can I do? How can I get rid of that exponent? Yeah, bring it in front. So this is 2 times log base 10 of 4. Now can I substitute in B? So for log base 10 of 4, we can substitute B, so what do we end up with? 2B. Okay. Let's do this one and see if we get the same answer. So remember, we can only substitute in for each one, so we have to break this up first. So log base 10 of 4 plus log base 10 of 4. And then I can substitute B for both of these log base 10s of 4. So what would I end up with? B plus B. Okay, how can I get 2B and B plus B? Are those the same answer? How many vote yes? How many vote no? Why no? One's multiplication and one is addition. Those of you that voted yes, why do you say these are the same thing? Yeah, you can still combine like terms. 1B plus 1B gives me what? 2B. So it's the same thing, okay? And really, if you decide to go this route on the right-hand side, I do want you to combine your like terms. So I do want 2B still as your answer, okay? So whichever method you decide to use, you're still going to get the exact same answer. But if you end up with this, make sure you are combining like terms, okay? Okay, let's look at a division one. So number 3. Log base 10 of 36 over 4. Do we have to manipulate any of the numbers here? No, but before we can substitute, what do we have to do? Separate these. Which rule is this one, guys? Subtraction. So this is going to be log base 10 of 36 minus log base 10 of 4. Does the order matter? What do you think?
Yeah.
Why?
Because it's subtraction.
Yeah, because it's subtraction. With addition and multiplication, the order doesn't matter because we have those, which ones? Commutative properties saying that the order doesn't matter. But with subtraction and division, there's a big difference between positive 1 and negative 1, right? Or 2 and 1/2. Okay, so order does matter. So make sure that your numerator is the first number that you're subtracting, okay? Okay, so when I substitute back in, I'm going to plug in A for log base 10 of 36, and it's going to be A minus B. Okay, so number 4, log base 10 of 2. And the reason why I changed is because you have one on your homework like this, so exactly like this, so I want you to see it. How can I rewrite 2? Obviously, we can't change a 2 into a 36, but we can, it is related to 4. How can I rewrite this 2 using a 4 without actually changing the value of 2? 4 to the 1/2. So what I see a lot of, and don't write this down, and I'm going to do it in pencil so I can erase it. I see a lot of students say, oh, well, we can turn this 2 into a 4 by rewriting as log base 10 of 2 squared, which is log base 10 of 4. Is that correct? No, because is log base 10 of 2 the same as log base 10 of 4? Definitely not, right? If we were to punch these into a calculator, we would get 2 very, very different answers. So what we want to rewrite it, or use a 4 to rewrite 2, and I heard you guys say it already. Log base 10 of 2 is the same as log base 10 of 4 to the 1/2. Now did I change the value of 2? Because what's 4 to the 1/2? 2. So these two things are actually exactly the same. Do you see what I'm saying? Okay, so we can only plug in B when we have log base 10 of 4 by itself, so let's bring that 1/2 in front. So that's 1/2 log base 10 of 4, and now we can substitute in B. So that's going to be, I'm going to go over to the side, 1/2 of B, or you could rewrite it as B divided by 2. I'll accept either one. So if you like it 1/2 B, give me that. If you prefer to not have a coefficient in front of the B, write it as B divided by 2. They're exactly the same. Okay, and both of those are considered a simplified answer. Okay. So you can never change the value of what's inside the log. You just have to use the numbers that you are given to rewrite it, the same number. Okay, number 5. Log base 10 of 1/4. I have close to log base 10 of 4, but it's not quite. How could I rewrite this so that I do have log base 10 of 4? Yes, log base 10 of 4 to the -1. So we just took that 4 in the denominator and moved it up. So then this is exactly like the one we just did. Bring that -1 out in front. So this is negative log base 10 of 4. So what does our answer come out to? Negative B. Okay. Last one. Log base 10 of 360. Any ideas? 36 times 10? Okay, let's try it. So log base 10 of 36 times 10. Split this up into 2 because we obviously can't plug in A yet because I still have this times 10. So this is log base 10 of 36 plus log base 10 of 10. And then let's see what we can do. What do you guys see? We can substitute A right here. Plus, what about this guy? I don't have anything for log base 10 of 10. Can we just keep it? I want my answer only with A's and B's in it, no logs. Can I? What's the exponent of 10? 1. I have same bases, right? So they cancel. So my answer is going to be A plus 1. So our goal here is to get our logs in terms of A and B, but if we have numbers being added or subtracted or divided or multiplied, it's okay. I just don't want any logs in my answer, okay? So if this was a log base 10 of 10 to the 3rd, my answer would come out as A plus 3, and that's okay, okay?